Let's start March 18. As we are solving, I'll mark كده some points, الpoints المهمة. The important points, I will mark it as we are solving, okay? Please mark with me. A student investigated the effect of temperature on the water uptake. I am investigating the effect of temperature. I want to see what does the temperature do to the water uptake. Therefore, this is my changed variable. يبقى I will write on temperature that this is the changed variable. I will change the temperature and see what happens to the water uptake. Water is transported in the xylem tissue in plant stems. One celery stalk was placed in a beaker containing warm red stain, and another celery stalk was placed in a beaker containing cool red stain. Any experiment with temperatures. Can I leave the beaker, the warm beaker, on the desk without monitoring? Therefore, لا, I cannot leave it. I cannot leave it because it will cool down or it will reach the room temperature. So this is a source of error. This is a source of error. يعني إيه؟ يعني it is something that will cause wrong numbers in your experiment. So you cannot leave the warm stain كده. You have to put it in a thermostatically controlled water bath. It is a water bath using electricity. It will keep the temperature warm or it will keep it cool. يعني it will keep it at the temperature you want. Okay, I put the stem in the beaker with the red stain. Both celery stalks were left in the red stain for 10 minutes. You put the same type of plant in both beakers, and both of them, you left them for 10 minutes. Okay. These are controlled variables or constant variables, controlled or constant, because you left the same type of plant for the same time. After 10 minutes, the stalks were removed from the red stain. A 5 millimeter section was cut from the end of the stalk, which had been in the warm stain. The section was inspected for the presence of the red stain in the xylem tissue. Okay, what's the idea in this experiment? When you put the stem in the stain will go up in the xylem. You are going to cut 5 millimeter piece, okay? And then check the stem. Check the cross section from here. If you still find red stain, this means that the red stain moved a little bit upwards. يبقى you will cut another 5 millimeter section. If you still find the stain, you will cut another 5 millimeter until the stain is no longer visible. I will cut 5 millimeter pieces until the stain is no longer visible. This means that it did not reach this part. Okay? The section was inspected for the presence of the red stain. Oh, I will check the cross section of the stem. If the red stain is visible in the xylem tissue, I will cut another piece. If it's not visible, then the stain did not reach this part and I will stop cutting. Oh, if the red stain was visible in the cut section, another 5 millimeter section was cut. It is repeated until no stain was visible. This allowed the student to estimate how far the stain moved up the celery stalk. By this way, you could estimate يعني تقريبا estimate how far the stain moved in the stalk. Okay. Steps 4 and 6 were repeated for the stalk in the cool red stain. I repeated the same thing for the cool red stain. Okay. State one safety precaution that should be taken while carrying out this method. In this experiment, you were cutting with a knife or a scalpel. This is the dangerous part about this experiment. So what is the safety precaution? The safety precaution is that you will use a cutting board. Use a cutting board to prevent cutting your finger. And then he gave me the results. The students' results are shown. Number of 5 mm sections cut from the celery stalk in the warm red stain was 11 sections, and the number cut in the cool red stain was 5 sections. He gave you the results. How many sections did he cut in the warm? How many sections did he cut in the cool? Prepare a table to record the results in the space provided. Your table should include the temperature of the red stain, the number of sections that were stained, number of sections, he gave it to you in the results, and the total distance moved. This is what you will calculate. In rules of the table, you should use a ruler to draw your table. Changed variable is on the left side, results on the right side. Changed variable is the temperature. I will put the temperature on the left side. The results I measured is the number of sections that were stained in 10 minutes, 11 and 5. Total distance. Each section is 5 mm. How many sections did you cut? 11. Therefore, the total distance is 11 times 5. And then 5 times 5. Please, usually we use millimeters in paper 6. Paper 6 prefers millimeters. But this is my table. Temperature on the left. This is the warm and cool. Number of sections, 11 and 5. Total distance will be 11 times 5 or 5 times 5. So it will give me 55 and 25. Use the data to calculate the rate of movement. أي حاجة فيها rate, you always use the time. Rate is something over time. Rate of movement, so I want to see the distance it moved over the time to know how much it moved, or the distance it moved per minute. Okay, I have the total distance. I have the total time. It moved 55 millimeters in 10 minutes. Therefore, if I want to get the rate per minute, I will divide 55 by 10. If I want to get the rate per minute, I will divide 55 by 10. It will be 5.5 millimeter per minute. Take care that he put the unit here for you. He asked you that he wants it in millimeter. So even if you calculated the distance in centimeters, okay, you have to change it here to millimeter before you divide. Okay, يبقى it will be 55 over 10, 25 over 10, 2.5 millimeter. State the conclusion for the results. The conclusion from my table, as I can see that in the worm, the total distance was more. So the conclusion will be the higher the temperature, the more it moves, the more the water uptake. As temperature increases, rate of water uptake increases. As temperature increases, rate of water uptake increases. Okay. Two variables that were kept constant. احنا already علمنا على الحاجات اللي kept constant. We already marked the constant variables here when we were reading. El celery stalk, the type of plant, we use the same type of plant. We soaked them, or we put them in the red stain for the same time. Also, the cut sections were all 5 millimeter. All of these are controlled variables that I can use. Controlled variable is the variable that I kept constant. I left them in the time in the stain for 10 minutes, the same. Size of sections were the same. Type of plant was the same. All of these. Okay. One way of improving the method would be to repeat. Identify two other sources of errors. We already marked one of the sources of errors. The first error in this experiment we already marked was the dye will change in temperature because you left it. You put warm and cool and you left it on the table. It will definitely reach the room temperature. What is the improvement? Anything with temperature, you will say that you will use thermostatically controlled water bath because it has an electric heater that adjusts the temperature to a certain level. The second error was about the size of the sections. If I have a stem and the xylem inside, the stain moved up the xylem, for example, 13 millimeters. We are going to cut 5 millimeter sections. So the first 5, you will still see the stain. The second 5, you will see the stain, okay? But it only moved up to 13. Let's say 13 is here. And you will cut the third 5 millimeter piece. You will record your result in the table that the stain moved 15 millimeters. However, in reality, it only moved 13. How to be more accurate is to cut smaller sections. Instead of cutting 5 millimeter sections, what if we cut 2 millimeter sections or 1 millimeter? So you will cut one and check the stain. One, check the stain. One, until you reach 13. You will find no stain. So you will record it as 13 millimeter and this will be more accurate. This was the second error. Cut sections are too large. What is the better option? The improvement is to cut smaller length of celery stalks. Smaller lengths of celery stalks. Okay. Question D. Some farmers wanted to investigate the effect of humidity on the rate of transpiration. This is the question for design and experiment. Effect of humidity on the rate of transpiration. What is the changed variable? It is the humidity. This is what I'm going to change. But what am I going to measure? The rate of transpiration. It gave me celery plants being harvested, the picture, and then he said, one method of measuring the rate of transpiration, you can measure it by recording how long it takes for the red stain to travel the xylem. So here he is measuring the time. He is not cutting pieces. He is measuring the time. Although if you wrote cutting pieces, it will also be correct. In this experiment, how is he measuring the results? He said that you can use this method. Record the time taken for the red stain to travel the xylem tissue in the stalk that still has its leaves attached. Plan an investigation to determine the effect of humidity on the rate of movement. We have 7 steps. The first step is to tell him the replica. How many plants are you going to get? And then, what is the factor you are going to change? Then, all the controlled variables. And then, your results. What are you going to measure? If there is an improvement, you will write an improvement. If there is a safety precaution, you will write a safety precaution. And then at the end, you write repeat and calculate average. Okay, so in this experiment, we will follow these steps. The first step is to tell him what are you going to use. I'm going to use 5 plants. 5 plants. What am I going to change? Put each in different humidity, and you should give him examples on the humidity you put in. 10%, 20%, 30%, 40, 50. I will put it in different humidities. Okay. Same temperature, same type of plant, same number of leaves, same light intensity. Any other factor that affects the transpiration should be the same. And then you are going to measure your results. You have 2 options. Either to tell him the first method that he used here, cut مثلا 1 millimeter section from the stem until the stain is no longer visible. Or you can tell him the other method that he gave you here, which is that you will record the time it took to for the stain to reach the leaves. The leaves will turn red. So you will record the time taken for the leaves to turn red because the stain will go up the stem to the leaves and it will change it into red color. Here I wrote the first method. Put a plant in a beaker with a red dye, leave it for 10 minutes, measure the distance traveled by the red stain in each plant by cutting 5 millimeter sections, or you can even make it smaller to be more accurate. Since you use the cutting, I will tell him to cut on a cutting board and then repeat the experiment at least 3 times and calculate average. Question 2, photomicrograph of a bronchus surrounded by alveoli and other tissue. He wants you to make a large drawing of the bronchus. Do not include any alveoli or other tissues. How am I going to draw? We draw outlines, an oval outline for the bronchus, okay? And then there is a second layer here, this layer with a triangular part coming out, the second layer. And then I have a third very thin layer. The inner layer is very thin, double lines, thin double lines, but take care that it is opened from here. So you have to make a break also from here. You can do these 2 breaks. But what am I going to draw is the oval structure, the inner layer, which is triangular, the middle layer, and double lines with a break. Double lines that have a tiny break between them. This is the inner layer. It is not continuous. This will be my drawing. It's not continuous. The inner lines are not continuous, and the 3 layers. That's another drawing for the same picture. As we said, oval outline. The second layer has a triangular extension كده on the side, and the third layer double lines, and has a break in the middle. It's not continuous. After the drawing question, you will have a magnification question. The magnification question asks you the diameter of the bronchus is shown by the line AB. Line AB on the image you will measure using your ruler. Say the number is 53 millimeters, 52 millimeters, it is 5.3 centimeter. You will change it into millimeter by multiplying by 10, and you have to include the unit. He gave you the actual diameter, which is 1.5 millimeter, and he asked you to calculate the magnification. The rule is magnification equals image over actual. So if you want the magnification, you will divide the image, which is 53, over the actual, which is 1.5, okay? And you will calculate it on the calculator to the nearest whole number. Write the number here. Magnification has no units. No units in magnification. Okay. The last question in this exam, a student investigated the effect of exercise on the breathing rate. Effect of exercise on the breathing rate. The breathing rate of 5 people were measured at rest and after running for different periods of time. So this is what you're going to change in this experiment. Each person will run for a different time. The people rested between each period of running. Okay. He gave you the table missing one value and he asked you to calculate the average. How am I going to calculate the average? All these numbers added together divided by 5. The average will be 40. On the calculator, it will be 40. Okay. The student thought that the result for person 2 at 6 minutes was an anomaly. Anomaly means that this result is wrong. Person 2 at 6 minutes. He thinks that this result is wrong. Suggest what could he do to determine that it is anomalous. How do I make sure that this is a wrong answer? To identify anomalous results, you have to repeat the experiment. Repeat the experiment for student 2 to make sure that this number is correct. If it gave you a different number, then you will repeat again until you find, okay, 3 times it gave you the same number. This one is different, so this one is wrong. يبقى to identify anomalous results, you repeat the experiment. Okay. Plot a graph on the grid to show the relationship between running time and the average breathing rate. Draw a line of best fit. What I put on the x-axis is the independent variable, the factor I changed, which is always on the left side. What I put on the y-axis is the results measured, which is the average on the right side. Okay. The first thing to do is to put the labels. Here I will write running time, and on the y-axis /minutes, you have to write the unit. On the y-axis, I will write average breathing rate, BPM, breathing rate /BPM, breaths per minute. Okay? And then you will start putting your scale. If the numbers are continuous, 0, 2, 4, 6, 8, 10, with equal difference between them, then you can put them as they are, 0, 2, 4, 6, 8, 10. On the y-axis, the smallest number is 24, the biggest number is 48. You do not have to start from the 0. You do not need the numbers before 24. You only need between 24 and 48. So you are going to, for example, write a scale, put 2 dashes to tell him that you're not starting from the 0. And I'm going to start with 20, 25, 30, 35, 40, 45, 50. Okay? And then I will plot my points. 0, it was 24. So how am I going to get the 24 here? You find the difference between the two numbers, which is 5 divided by 10 boxes. So each box is 0.5. And the 0, it's 24. So it's here before the 25 by 2 boxes. 2, it was 31. This is 30, 30.5, 31. 4, it was 40. And then 48, 48, 48. Where is the 48? This is the 45.5, 6.5, 7.5, 48. 48, 48, 48. Okay. Take care here that he said draw a line of best fit. Draw a line of best fit. If the points are scattered, but they are all increasing, we draw a line of best fit in the middle using a ruler. But if the points look like a curve, we draw a curve of best fit. It's still a line. The best fit here is a smooth curve passing through all the points as much as possible. This is the curve of best fit. Use your graph. Estimate the average breathing rate for 1 minute. Show how you obtained your answer. Okay, and the 1 minute I have to draw on my graph. How did I get my answer? And 1 minute I will go up until I reach my graph, and then I will go to the left side. It gave me 27.5. The number you get might be a bit different. Each of you will get the number he reads from his graph at 1 minute, and then you will go left and tell him the number you read. There is no correct answer. It is according to your graph. Use your graph to describe the relationship between the running time and the average breathing rate. This is a description question. Use the graph to describe what happened. Between 0 and 6 minutes, the average breathing rate increases from 24 till 48 breaths per minute. You have to use the units. Starting from 6 minutes, it is constant, or it levels off. It starts to be constant from 6 minutes, and then it remains at 48 breaths per minute. So here you are just describing. I am describing, okay? As the running time increases from 0 minutes to 6 minutes, the breathing rate increases from 24 to 40, and then it stays constant at 48. This is the description. Right. If you noticed here, I wrote 26.5, not 27. This is another graph I drew because here, when I drew, it's according to your hand. My line shifted a bit lower. Okay. So when I met the point, it was at 26.5. This is what I'm saying. There is no correct answer. It is according to your drawing on the graph. You just have to read the number correctly. Okay. Suggest one safety precaution for this experiment. Uh, in this experiment, the safety precaution is something related to the running. So I can say suitable running shoes, make sure they don't have any health conditions, wear knee protectors and helmets, something to protect their heads and knees if they fall. Okay, anything related to the running. State two variables that should be kept constant. In this experiment, you changed the running time. You changed the time of running. Some were running for 1 minute, 2 minutes, 3 minutes, 4 minutes, and so on. So what should I keep constant? Every other variable should be kept constant, like the age of the students, the gender of the students, the type of exercise, the temperature around them, okay? Any other variable that might affect the breathing rate should be constant. The last question was state the variable that was changed in this experiment. As we said in the beginning, he changed different periods of time, so he changed the running time. This is the independent variable, the changed variable, which is the independent variable.